Okay. Good afternoon and good morning. I'd like to welcome you all to the U.S. Cloud Application Development Partner Community Call. I am one of your hosts, Wayne Smith. With me is my partner, Jonathan Gardner, and we'd like to once again welcome you to our discussion today. We're going to have a discussion given to us by Serverless Computing with Chris Anderson, who's be presenting. And I wanted to let people know we will be recording this call for Microsoft so that we can take a look at it a little later, and people that have not seen it can take a look. So, without further ado, I'm going to pass this over to Chris. Chris, welcome and thank you.
Hey, thank you, Wayne. I'm going to go ahead and take over presenting.
Thank you.
And I can see infinity there. Let's go ahead and get started. So the idea here is we're just going to walk through kind of an introduction to what serverless computing is, what Azure Functions is all about, and some real-world examples of how people are using functions. And then we'll also dive into some more technical demos here as we go along. This is, this is for you guys. So if you guys have feedback that you want to, dive into the technical stuff sooner, go ahead. If you guys have any questions at all, just go ahead. We've probably got more content than time on the call, so it's really up to you guys to kind of drive things in a different direction if you want different information. So definitely feel free to speak up and let us know. So this is roughly the agenda that we'll go through, just why serverless, what is serverless, intro, and then some patterns. So this is our whole spiel on why serverless exists in the first place. So before the cloud, you'd go to the store, you'd go ahead and you'd set up some kind of co-location or on-premise machines, and then you deploy your business applications onto a bunch of servers that were there. And then your applications can finally connect to those things. But it introduces a ton of questions that you have to solve before you could even get to the point where you were actually deploying something. So all these questions had to be solved before you could even start to do any work at all that was valuable to your customers. But then we had the cloud come in and IaaS, and this allowed us to go and have virtual servers that we could spin up whenever we needed to without having to go ahead, call up a colo or anything along those lines. And that helped to reduce some of the problems that we had. How long does it take to actually provision a new server? What size of server should I buy ahead of time? What happens in case of server hardware? A lot of these things are just kind of done for you, so you don't have to be thinking too hard about how am I going to be able to manage these things. You get to just focus on, well, I have this VM, and I need to just make sure that the VM itself is working properly. So really, it was a huge leap forward in terms of how useful it was to, or how quickly I could build an application. And then PaaS kind of comes through there with things like Azure App Service and other similar products. And it helps to reduce things even further by not even having to think about, like, which OS do I need to bother? How often should I bother to patch my machines in the first place? Other kinds of things like what packages should I have in each of the images, things along those lines. And there's a lot of features that come with a lot of those services, like they have automated deployments to those machines. They'll go ahead and help you with backups automatically. And, they'll help you configure your application in the first place. All these various things that you have to normally solve, PaaS solved for you. But we still had just a couple of questions left, and these questions ended up still being pretty hard. How do I scale my application? What is the right size of the servers for my business needs? How many servers do I need in the first place? And how do I increase server utilization? All these questions can, really go away once we have serverless in there, because I no longer have to be thinking about those servers. It's going to automatically scale and handle those pieces for me. And so really what we have is we have a new question is how do I architect my app to become serverless? Because serverless really is a new paradigm. This little middle box here with the smiley cloud full of applications, it's entirely different than all the previous pictures before then, because now we're writing just functions in this case. We're writing small little components that can each scale individually separately from the others. And that's what some of the real magic there is why you're able to get these awesome features, but it also means some different changes to how your application is built. So talking about how it's different, you have normally a monolithic application that you deploy, or maybe a bunch of microservices that you're still deploying them as a bunch of larger self-running applications. They have all their dependencies, all that kind of stuff connected with them. And now you're writing a bunch of loosely coupled components with serverless. So I'm not going to be worrying about having everything all together at once. It's just going to be loose and not very tightly coupled. And that also means that I'm going to go from having a very large, complex framework that's going to have like all of my state management, everything all together in the same place. And instead, I'm going to have a bunch of micro functionality. So I'm going to go ahead and try to follow a more microservices approach. I'm going to go ahead and try to avoid doing things which are normally necessary for running a very healthy, single server, but with functions, it's just not quite as necessary. There's a lot of things where you can just take advantage of that horizontal scale that happens automatically for you with serverless. And that of course also means that I go from thinking about managing VMs to managing applications. And so what this does to an applications architecture over time, we've already been going down this path already, fortunately. So it's not too foreign for people who are kind of adopting serverless. So, for a long time, we just had, giant monolithic applications where you'd have your client, your database, all your various pieces, all potentially on the same machines. And microservices started to kind of break that up. So now it was easier to distribute these things across the various machines and hardware that you had and things along those lines. With functions, we take microservices and we kind of take it, even kind of to that next level. And you break these things up, and you're still going to think about a bunch of pieces. With serverless, you're just going to break these up into a series of functions. And so now all those calls that I was previously making are each now represented individually as function calls. And so what is serverless? How does that get to things in the end? And thank you, teams, for ignoring my silent settings. What is serverless? So it's about abstracting away the server. And when we say server, we're not talking about just hardware. We're also talking about a logical abstraction of the server. So I wouldn't have to worry about how to configure my ASP.NET, web API, or my Express server, or my Django server, or my Tomcat server. It doesn't matter. I'm just going to be writing individual functions. And that's what's going to be important for me here. That also, the other big thing there is being event-driven, which also gives us the ability to scale. Some very good qualities of very nice microservices and things along those lines is that they scale horizontally, quote, infinitely. It's kind of hard to do infinite, but, to a large extent, they'll scale infinitely. Based off of events that come in. That's the pattern of very, very highly scalable services. And functions ends up meeting that pattern really well. A really well-written application in Azure Functions is going to be able to go ahead and scale horizontally for a long time before things start to kind of reach the ends of their limits and things along those lines. We have customers that are doing huge amounts of load without ever having to call us to figure out, well, what's going on with their scale? How do they move to the next level? It's just kind of a natural thing if you write your application in such a way that it takes advantage of things that do scale quite large, things like event hubs, etc. And the other great thing about this is that you are only going to pay for what you use. Because we're billing you on the 100 millisecond bucket increments, essentially, you only pay for what you're actually doing outside of the servers themselves. So if you have nothing going on, you're paying nothing. If you have 1 or 2 requests an hour, you're paying for those 1 or 2 requests. If you have 1 or 2 requests a second, you're paying for only those requests. If you've got 1,000 requests per second, you're paying for those. And you don't have to worry about how if that scale changes from 1 or 2 requests a second to 1,000 requests a second, and then all the way back down to 1 or 2 requests a day. You never have to intervene to go and configure how much capacity you've allocated for your backend. It's automatically done for you. So there's a sense of management there, both in terms of keeping it up and running so that way everything's healthy, and also from a cost savings point of view. You don't have to go back there and remember to shut down servers that you didn't need, things along those lines. It all just takes care of itself.
So we did have a question. What's the difference between serverless and the container model?
So that's a really good question. So containers are all about trying to abstract away the applications that are running on your machines. And a lot of the container orchestration services like Kubernetes are all about trying to then kind of also take out a bit of abstraction in terms of how those containers are then distributed across your various machines. So containers themselves have a lot of interesting pieces, both from how do you maintain your applications when they're running on the servers, as well as how do you deploy those applications to the servers. A lot of those container services help with those pieces. But you're still going to end up having to buy VMs to run them on. You're still going to have to provision ahead of time enough capacity to run your containers on there. The nice thing with containers is that if you have enough capacity that you buy ahead of time, a lot of those services like Kubernetes or Docker Swarm, they'll actually help you load balance your containers onto the right machine. So if suddenly you get a lot more requests on one of your services and you have available room, you can grow out that service independently of your other services because they're all decoupled. Ideally, you've built them so they're decoupled. And so that's one of the advantages of containers is that I still have to maintain my own I still have to maintain my own capacity. I'm still responsible for scaling up and scaling down and setting all those things up so it works the way that I need to. But containers help me do the abstraction of my applications over those machines. And so I don't have to worry about setting up and getting the machine set up correctly and all those kinds of things. It's done to be very reproducible. And the other nice thing about containers is that I can deploy my applications how I want to. Containers make it very easy to bring most applications onto those machines, and there's not a whole lot of restrictions. The problem, of course, is then there's a lot of things that I'm still responsible for with containers. I'm going to be responsible for, of course, making sure the VMs are set up in the first place. There's a lot of services like ACS that'll help you go ahead and set up the orchestration services and set up the machines that they're going to run on. But you're still going to have to go and define the rules for scaling. You're still going to have to do a bit of work in terms of deciding what containers should be taking, more space and scaling up the number of containers within your amount of hardware that you have. And so you have that scaling problem you still have to be concerned with. And with that, you also have just the cost of running all of those machines all the time. If you're not doing the right job of scaling back down afterwards, it's going to cost you. And let's say that your workload is less than you need a single VM for. Let's say that I just have a timer job that runs once a day. Having a VM sit around for forever or micromanaging that VM being up and then down again at the right time, that's a lot of stuff. Sometimes it just doesn't pay to have all those things in the way. Serverless is all about trying to abstract away the servers themselves. So rather than trying to abstract away the applications on the servers, we're fully trying to get it so that you don't even think about the servers. And it also changes the way you write your code. You're generally writing functions. You're not writing full-fledged applications that would run inside of a container. When you're writing applications for containers, you're not writing them any differently than you are writing them for app service or just running on your own plain VMs or worker roles. So really, serverless takes it to kind of that next level there. And there's a lot of advantages, but there's also a lot of caveats there. You have to write your applications differently. You generally can't bring your own data services. So you can't run a database on functions. You have to go and rely on PaaS databases or setting up a database on a container if you wanted to do that. So there's a lot of different ways of thinking about building your applications. There's a lot of advantages to functions because there's a lot of things that are just taken care of for you that still aren't taken care of for you with containers. But there is a certain amount of freedom that you give up. And the problem is with freedom comes responsibility. And so we're taking a lot of responsibility for you. But that means that you do have to kind of play by our rules more or less to be happy, that is. And so talking about those benefits then, essentially you get reduced DevOps, right? Because you're not having to worry about, well, how many machines do I have around? Are those machines being patched and imaged? Is antivirus working on them properly, et cetera, right? Like, we're doing all those things for you, so you don't have to worry about having those things run and be healthy. If one of the machines is misbehaving and acting unhealthy, we'll tear it down automatically for you. We have lots of health metrics and monitoring to make sure that we're making sure that the VMs themselves are healthy, even beyond your applications that are running on them. That lets you then focus more on writing business logic and writing application logic rather than having to write infrastructure and, kind of the overhead. A lot of things that we've done as developers over time has been creating a lot of smart ways of solving technical problems that we had to introduce in order to solve the actual application and business problems that we had. If I'm just trying to build an e-retail website, something along those lines, all I really needed to do is go ahead and be able to receive orders, receive payments, and do processing behind the scenes. And I can take advantage of, PaaS services like DocumentDB and Service Bus to handle, keeping track of all of my orders and keeping track of, actually the processing of orders with queues. And then functions fits in very nicely for running all the various pieces you have beyond that. And I can focus on just the things which make my business move fast. It's easier to respond to like digital marketing requests and things like along those lines. And so that's a big advantage of using functions because a lot of things are just done for you. And that, of course, all kind of equals reduced time to market and lower maintenance costs once you're actually in the market. And that makes it so that you can move faster. And so if your team, if you have got a customer or anything along those lines where your concern is about trying to deliver something as quick as possible, functions is a great way of getting started because it's very fast to get started, and in general, it's very fast to actually deliver something end to end. Fancy graphic here. So those are all the servers that you no longer have to concern yourself with because there are servers and you don't have to manage them, so they're all gone. And that's just replaced with functions. So talking about serverless, this is all about serverless compute this session. We're not going to go dive too much into some other places, but it's important to note that we do think about serverless also from the point of view of logic apps. And then we are kind of coming around to the idea that a lot of other services that we have are serverless or close to serverless in a lot of cases. And we're working hard on trying to like solve some of the edge cases which make it hard to scale and scale horizontally, very cleanly with some of these services. But a lot of these services are approaching that point where there's not a lot of maintenance to deal with as you scale up. They'll scale out horizontally along with your applications. And so while we're focused on functions here, you'll see Microsoft's strategy evolving more and more to kind of talk about the broader range of PaaS and fully managed services that we have and how they fit into a serverless application. Even if the underlying service itself isn't truly serverless, it's still generally functional within a serverless application model. So getting to Azure functions themselves, and I know that was a fairly long-winded intro, but I kind of like to set that stage of like, what is serverless? Why should we be excited about it? It is it's a paradigm shift, but it's a very, very productive paradigm shift for those who make that leap. So Azure Functions is really started with just this idea of I want to be able to write a bit of code and have it be react to events and allow me to easily access my data without having to write a lot of code. So I wanted to write some code, the logic, business logic, etc., but I don't have to worry about the infrastructure management. I don't even really want to worry about having to use SDKs if I can avoid it. I really just want to work with kind of, simple objects, simple code just to perform my business needs. And so that's why we get our awesome logo, BAM, for Azure Functions, as we took the Microsoft design language for code, which is that little bracket thing, and the Microsoft design language for events, which is this lightning bolt, and we just slap the two together, and that's how we get our functions logo. So just to dive into a quick demo here for how this stuff will end up working. And cool thing for you guys today is that we have a new UX kind of coming out here soon in the next 2 weeks or so, I think. And so I'm going to be demoing on that because everyone on the team is kind of eating our own dog food and trying to use this as much as possible before we start having everyone else using it. And so you're going to see me demoing this in the new UI. If you go to the functions portal today, you're going to see something slightly different. I can just go to the normal portal and show you what you'll see. The way that you would normally today go ahead and get started with functions is you would go and click on New. You would search for Function App. And then you just click on this, click on Create, and you just fill in these details here. Some interesting notes about this is this hosting plan. Consumption plan is the serverless plan, but we do actually let you run your function apps on app service plans, which are just dedicated VMs that you buy ahead of time. So let's say that there's some reason that you didn't like this whole serverless thing that I've been trying to sell you on for the first part of the call, and you really just wanted to run this thing on servers that you managed. We'll still let you do that. And it's a great way of, if you already have an app service plan, you already have web apps running, and you just want some background compute, it's actually a great way of just adding like a timer to an existing app service plan without having to pay any extra money at all. So that's just an interesting note there. Most people should be happy with a consumption plan, but this app service plan is a really nice thing for a couple of weird corner cases that people will run into. The other thing to note here is that every function app requires a storage account for some of the underlying monitoring pieces to work, and so this is just something that you always have to have. We'll automatically create one for you, but you can go ahead and click on Create New and give it a more intelligent name if you want to. Just you have to make sure that you use a name that storage likes. So for instance, storage does not like dashes in their names, and so this is going to yell at me if I try to use it because it doesn't like the dashes. I have to make sure that it's all just lowercase numbers and letters. So I already have function apps that are provisioned, and so I'm not going to go through any work. In the normal portal today, you're going to go ahead and just go to the app service plan section, and then you'll see inside of here, there's a ton of stuff in here. You'll see like a function app. So this is our coder cards demo that we've got. And then this will go ahead and open up this portal here where you can go ahead and edit your functions inside the portal. If you haven't created any functions at all in the first place, you'll go ahead and you'll have this getting started piece here. And like this will create an HTTP function for you, this will create a queue-based function for you, this will create a timer-based function for you. But you can also do fancy new function create from this plus new function. This is set up to read from GitHub right now, and so it's not letting me create new functions, so it's just giving me this warning that you can't create new functions if you've set up CI. We basically don't want you writing new code if you set up CI, because if someone does a git push on your branch that you're listening on, it'll overwrite your code, and then you've lost all of your work. So we generally try to make sure that you can't hurt yourself. But we're going to be demoing in the new UI, and we don't have an app which has that, which has CI set up right now, so we can go ahead and just jump into this. And so if I were to go to my functions here and go to hello, so this is a function which is actually just going to return to me some HTML in this case. It's a very, very simple function. I can copy this function's URL and just paste it here into the browser. And you see here that I get, hello world back. And because I formatted this with a pre-tag, I actually get it with all of like my white space preserved and things along those lines. So, this is a very simple example. If we look at the code here, this is JavaScript. We're able to go ahead and just do a new response object, and then I'm passing that in as the output of my function. And then so we're going to be sending this body, which in this case is just this HTML that I've got, and I'm setting my content type equal to text HTML, so that way the browser, when it gets it, it tries to render it as HTML. I can set it to application JSON or XML or whatever flavor of response type that I'd like to go ahead and do there. And so we really have full control over what that body ends up being in this case. For those of you who are more C# inclined, here's not anything which is too complex here, but I've got this one added with a bit more telemetry information here. So you can see here that I'm using application insights, and I'm actually logging out some custom metrics and events and dependencies here. So, this code could be a little bit simpler for just a hello world, but in this case, I'm just instrumenting it with a bit of code. But in this case, I can go ahead and copy this one. And some of you guys may have seen this demo if you've watched any of the function demos that we have, but this is normally our hello world demo. And you see that the response that we get back is, please pass a name on the query string or on the request body. So I go ahead and do name equals world and name equals world. And I get hello world back as my response. This is C# script, so it means that we're able to actually compile it inside the portal for you. So in this case, let's say that we wanted to get very excited that someone gave us a name. I can go ahead and add some exclamation marks. I can hit save, and if we go open up our logs here, you'll see that we actually saw that the script for CS HTTP changed, and it compiled successfully there right in the portal. This really just kind of speaks to how fast it is to get started with Azure Functions. We started the project with a goal of being able to get started in, I think our goal was to get started in a minute. So you'd have your function app created and all that kind of stuff ready in a minute, and then you'd have your first function created doing something in 5 minutes. So this is kind of our whole thing there, where we really wanted to make it easy to get started quickly, which meant making it so you could compile C# in the portal. That said, we have a lot of tools locally with Visual Studio that let you work with proper class libraries and things along those lines in case you don't want to use C# scripting. And we often find people will get started with C# scripting and then move on to traditional class libraries as they decide they want to write more complex applications with functions, which they totally can do. Functions is not just for simple scripting activities. So in this case, I had saved there, so I can go refresh this. And I get those exclamation marks immediately. In this case, I was talking, so maybe it doesn't look immediately to you, but I can go ahead and just to prove myself, I'll add a question mark at the end of there, add some, because we're questioning this, and go refresh, and you see here we have the question mark. So C# automatically up there, ready to go that quickly with just a simple save inside the portal. There's a lot of other functionality that we have to offer inside of this, just to kind of walk you through our base scenarios that we've got. A lot of people who use the predecessor to this technology, which was just web jobs, was actually using it to do like scheduled tasks. So in this case, I'm going to go set up a timer triggered function, and this is going to run on a schedule. This is a cron expression. I'm not sure how familiar people are with cron expressions, but they're very easy to write once you learn it. Essentially, what I'm going to do here is I'm just going to change it so it runs every 30 seconds. And we can give this just a bit more of an easier to read name. So I'm just going to change this to C# timer as my name. I'm going to create this. And we can kind of see here from the streaming logs that we have when this will run. So this is going to run twice a minute, so we'll expect to see this thing kind of run here in just a second. But one of the things that we can do is we can also use something that we have inside of the functions world called bindings. And I'll talk a bit more through this in the slides that we have to come. But I'm going to go ahead and just add an output to a Azure queue, an Azure storage queue in this case. So I'm going to select that, and I can name the parameter that I'm going to use inside of my code whatever I want. I can name the queue whatever I want. I'm just going to go ahead and add some random numbers here so I don't overwrite any other queues that I might have inside there. And I can just use storage. I can set up my storage account connection that I want to use right here. You automatically have a couple of connection strings set up for storage automatically, but I can always click on New, and this will open up a blade for me to go ahead and set up a new connection to a different storage account that I have. By default, it only shows you storage accounts in the same region as your function app, because that's the good practice performance-wise. If you want to create one in a different region, you'll have to go ahead and set it up manually via an app setting. So once I save this, I can then go back to my timer, and you'll see here that we'll actually get a warning that we're missing a binding for output in this case, because it's smart enough to detect that we could have had that output. And I'm just going to do out string output. And now I can go ahead and do, inside of this one, output is equal to hello world. I can save, and we'll get compilation warnings if we had any down here. For instance, if I forget to put out right here, we'd get a compilation warning because you can't just have a string as your input type. You have to be able to do out string in order to return a value there. We have a couple of other ways of outputting stuff to queues. For instance, using an iCollector, a type that we have, which is basically just a giant list that you append to, which is more generally used. But this is a very simple way of getting started, and this is just a hello world demo. So you can see here that we've had this run a couple of times. And so we should have a couple of queue items waiting for there. So we can also take a look at our queue trigger that we have. And to make it easy to create a queue trigger, we actually, we used to have, now I guess in this new UX it's now missing, so I'm going to go and create this manually. What we want to do here is we want to take a look at our output queue and just remember this queue name. So I'm just going to copy that. And then we can go ahead and create a new function. And just to kind of prove that this can be language independent, I'm actually going to go ahead and have a queue trigger with JavaScript react to that timer trigger that was written in C#. So I can actually work with multiple different languages there. And so I'm just going to do JS queue. Apparently it didn't like having queue in the name. I'm not sure why that is happening. I'm going to have to go look at that later. But you can see here, as soon as I created the function and it's now listening on that queue, it automatically started pulling things off of that queue. So like, it took no time at all once we created this function for it to go out there. And you can kind of see here that we're getting JavaScript trigger function process to work item hello world. And it was in no time at all that we started that, and it started pulling items off of the queue. So it's a very easy way of going ahead, and you can see here how it flowed. We had a timer, which is now outputting queue messages, and we'll see this thing go ahead and pop open again about every 30 seconds every time this happens. And you can see here that the delay between when we drop the queue message on, because this is running every 30 seconds, right? So if you look at this thing, there was 60 milliseconds between when we dropped the queue item on there and when it was picked up by this function to process. So it's a very, very fast processing system that we have going on there to react to all these various events. So that covers all the hello world scenarios that we've got. So now let's go ahead and talk about a bit more about that programming model that we've got. Just looking at the time, 30 minutes. So what you're always going to have for a function is you're always going to have a trigger. We have to know when we want to run your function. We have support for, I think, 7 or 8 trigger types, HTTP and webhooks, timer, service bus queues, service bus topics, Azure blobs, Azure queues, and then timer, and then the 8th one there is a manual trigger, so you can trigger it only from the portal. It's not, I don't really call that one a trigger because it's not really a trigger, it's you going in there and hitting the run button, but technically you can make it so it's only able to be run by you when you're in the portal. Optionally, you can set up additional inputs. So this is really useful for something like image processing. Let's say that I wanted to upload an image to blob storage and I wanted to resize it, a couple of different sizes, and it might be a dynamic number of sizes. It would depend on what the user requested when they uploaded the images in the first place. I can actually go ahead and write a function which will take in a queue, which will have a path to a blob on it, and then this size that they want the image resized to. And then I can drop multiple queue items on there pointing at the same blob with just different sizes. And then I can have a new input trigger, which actually will grab that path from the queue message and grab me a blob. And then I can have that blob brought into my function without having to reuse any SDKs whatsoever. So I don't actually have to go ahead and take that information and then bring in the Azure Storage SDK and go and grab that blob myself and handle all the best practices for talking to blob storage and handling streams. None of it. You don't have to do any of that. All you have to do is add an input binding to blob storage, telling us that you want the path off that queue message to tell us where that blob is via the integrate menu. It's very simple. And then in your function, you can go ahead and just request a stream data type, and it'll just work. It'll give you a stream to that image every single time that queue message comes in there. You feed that stream through your image processing library, which just hopefully will take a stream in as an input. And then you can have another blob output, which will be the output of that, which will go to another blob storage, which is saving all of your resized images in there. And then you can have it just fully be streaming, no storage dependencies whatsoever inside of your code. It's just working with streams and queues as the actual trigger. So it's a very useful piece there. And speaking of outputs, you can have many different outputs here. This is doing an HTTP response as an output. So with HTTP, since it's asynchronous, you set up your trigger and you set up an output, and your output is the response to that HTTP message. It's optional, so if you don't have an HTTP response, we'll just return 200 OK if things worked, or a 500 if things failed. But you can control it yourself if you'd like to by using the task HTTP response message in the C# case. Outputs are actually generally more commonly used than inputs. A lot of the times we have a single trigger, and we have a lot of different things that we want to output from that trigger. For instance, if I wanted to have an order processing function for my website for every single time that they checked out, I want to go ahead and send all of the orders to the warehouse to go and ship the product to the user. I could go ahead and have an HTTP function which accepts that order, and then from it outputs not only an HTTP response to the website saying, yes, I worked, but it also will go ahead and output stuff to a queue to go ahead and begin processing that order, and some back-end function that's in the warehouse will go ahead and manage getting the warehouse to go pull the things off the shelves and put them into the right package and send that off to the user. All of your bindings are expressed via something called function.json, which when you're using the portal, you don't have to interact with because we have that nice integrate tab, which is just a visual representation of that JSON. But if you're working locally, you would actually see that JSON and use something like our JSON schema to get a bit of intel sense as you're writing it. The nice thing about having it inside of a JSON file like that is you can check it in with your code. So when you go ahead and deploy out a new function app with all of your functions inside of it, you don't have to reconfigure everything from scratch. It's all expressed via JSON that you can check in with your code, and your secrets are just stored as app settings, environment variables that you can reference. In this case, you can see here, I have this connection called Azure Web Job Storage, and this is actually just a reference to an app setting. For other types where they don't always expect an app setting, you can actually just use percent name of my app setting %, and we'll go ahead and know to fetch the value from your app settings. And that's a very useful feature if you want to go ahead and make sure that you can update your queue name when you update a new app, things along those lines. So this is just an overview of all the binding and triggers that we have. Like I said, schedule, HTTP, blob storage, we've got queues and blobs there, event hubs, and then not listed on here for some reason is service bus queues and topics. But then we also have input and output for a lot of various services like DocDB, table storage, mobile apps tables, and push notifications to Azure Notification Hubs. We also have output bindings for SendGrid and Twilio. So if you're trying to send a lot of emails or texts, you can use those bindings to easily use SendGrid and Twilio without having to muck about with bringing in their SDKs. We'll do that automatically for you. So we're going to skip that demo and kind of move down towards just some final pieces here. So dual abstraction. So the serverless compute abstracts away the compute. It also helps you abstract away the services you interact with. So you get to have your function focused on business logic. You get to rely upon that compute, abstracting away the scalability, things along those lines. And then because of the richness of the functions framework, we'll also abstract away the services you're talking to there. So you saw there with all the code samples we just showed you, I was never using an Azure Storage Queue object or anything along those lines. I was getting strings and POCO objects or just regular JSON objects to work with, and never having to actually worry about how the SDK itself is going to work, not having to worry about like SDK version updates, things along those lines. They're all handled for you by the framework. So when you're building applications with Azure Functions, instead of pulling, you want to be wanting to go ahead and rely on triggers and pushing. Instead of bringing in SDKs, you can use bindings. Instead of implementing a route instead of web application function, a web application server, you're just going to write a function which is listening on a given route, which is, fundamentally the same, but there's no longer that precursor step of setting up the web application server to listen for the route. All you're going to do is write the function and tell the function that it's going to respond on a given route, and then the framework will do it for you under the covers. You don't have to write giant functional tests against a server. You can write things that look a little bit more like unit tests when you're trying to code against these functions, because the function, a unit test is generally against a single function, and here you're writing individual functions as your output. That's not to say that your function doesn't call a bunch of other functions, and so you're not going to have unit tests for all your backend libraries that you call and things along those lines. But your functional tests, the end-to-end tests, they look a little bit more like unit tests. They're quite simple. And then building and deploying servers is really deploying a collection of functions. You don't have to worry about the servers themselves. You're just going to be you're going to be deploying the logic, and not really the actual server and how it's going to be configured itself. And so some best practices for this is functions should attempt to do one thing. Think Unix command line philosophy and microservices and all that kind of stuff. You don't want your functions to be trying to do more than one thing because it makes them a little bit less predictable in how they're going to behave. You want to be kind of trying to shoot for deterministic applications. Your functions should try to finish as quickly as possible, both for reliability and for billing purposes. The longer a function runs, the more likely it is that it fails for some odd reason. And you want your function, you don't want them to fail because then they have to retry, and if there's some percentage that's going to fail the first time, there's that same percentage that will fail the second time. And you can run into some issues where if it runs for too long, you're just introducing unreliability in your system that you don't need. Plus, you're being billed for stuff. So if you can, it's better to use like asynchronous models than synchronous models, where you're not going to have like a chain of dependencies where they're all calling into each other, and they're all being kind of double charged as they're waiting around for responses. Functions should try to be stateless. It's not always possible, and sometimes there's actually even performance benefits for adding a bit of state. So for instance, having some kind of in-memory cache that you can reuse between executions, that can be valuable. But you should always be able to be stateless. You should always be able to start from zero in as efficient way as possible, and then use state only for optimizations, not for a raw requirement for your application to work. If you're always starting from scratch in your application with your function, it should be successful all the time. Just look at state as a way of optimizing performance. And kind of to that deterministic point, functions should be idempotent. You really want to be able to run the same function twice, and it should try to behave as similarly as possible. That's not always possible. If you've got some random number generator or you're trying to rely on a date as part of a thing, it's not going to be fully idempotent. But for the most part, you want it to try to be as idempotent as possible, because that will really reduce a lot of headaches that you'll have with your application as you're going along. So let's get to the meaty pieces, because this stuff's a bit more interesting than kind of the high-level hello world pieces. So what are people building with Azure Functions today? There's an awful lot of timer-based processing functions out there. For instance, I've got a table in SQL, or I've got a bunch of blobs in blob storage, and I just want to go ahead and remove old things or things that don't look valid anymore. And so every 15 minutes or every day or every week, I can have a function start up and go through there and look for anything which looks bad and clean it up. This is really useful, for instance, with Azure mobile apps, where Azure mobile apps has the ability to go ahead and do offline sync. And that means that you have to keep old records around even after you've deleted them. They're just marked as deleted, but they're not actually removed from your SQL table because they need to be around long enough for all the mobile apps to sync. Well, it's probably safe to delete data that's like a week or two old, because if in your scenario, you could say that most mobile apps will eventually connect at least once a week. So you say that any old data that's older than 7 days, we can go ahead and delete if it's marked as deleted. And that way you can save on space inside of your SQL table, and it doesn't just keep on growing and growing and growing. I can use a function to very simply clean that thing up and just maintain it for me without having to ever have a weird case where, oh, we have an alert because no people are able to make new inserts to our database. Oh crap, it just grew beyond our control. You can write a function to help automate that, so you never get into that point in the first place. And if this runs once a week, you're probably not going to pay more than a nickel a month for it. So it's an amazingly cheap way of going ahead and writing this, basic automation task. One of the ways that one of our customers used for this is that they had a whole bunch of random FTP things that they had to download. Like, think of like thousands and thousands of FTP servers, all with their own idiosyncrasies and all that kind of stuff that they've got to connect to. And before, they were just writing a server that's kind of continuously ran and pulled things from the FTP. And they moved it to functions, because functions, you could go ahead and just move it over to using a timer, and it would go ahead and download it. It'd put it into blob storage, and then they would have another function which then actually took that blob and turned it into data that was parsable. And then they processed it with stream analytics and had the Azure function react to abnormal behavior. And it was a very smooth process there. And before functions, they'd have had to set up a VM container or a web job. They'd have had to build, patch, and deploy, monitor the scalability of it, and figure out the Azure SDKs. And in this case, they just worried about setting up the FTP stuff, and then used an FTP library to actually go and pull things from FTP, and everything else just kind of worked magically for them. And we ended up recommending an optimization for them, where they essentially had a timer go through there and schedule a bunch of queue items to go and pull from the FTP, and then push that into blob storage. And that was even more reliable, because if one of those timers failed, before if that timer failed, then it basically would wait another 5 or 30 minutes or however long that it configured before it would pull from FTP again. But when you use queues, we have baked-in retry. And so it would, if it failed to download from that FTP service because the FTP service was down or something along those lines, that queue is durable. And so if that failed, it would be retried again. And if it failed too many times and hit our poison count, it would then go into a poison queue, which you could write another function to then like send you a text or an email or whatever you need to go and react to the fact that one of your FTP servers that you're trying to rely upon for data is down. And so you can fully automate the process. You don't have to worry about this except for when another service outside of the functions world starts to go down, and then you have to get involved. So then you have something like Azure Service Event Processing. So for instance, in this very simple scenario that's just in the marketing graphic here, a file's uploaded to blob storage. Maybe it's a CSV file, and I want to transform that to data, like putting it into a SQL database. And then that SQL database can be hooked up to Power BI, and now I can have my Power BI chart, with a graphic hooked up to it so I can see things. We actually saw this being really interesting, not for a CSV data type, but there was a legal company that had their own proprietary legal document format, and they needed to basically, every single time that it was uploaded, because they couldn't move their old system off that old data format, it's just the way that everything else worked, but they wanted to be able to start using a more modern data format like JSON and other things to represent that document. So they automatically were transforming those documents in close to real time with functions and doing a lot of other things like from that document they were capturing a bunch of the metadata and storing that off to a database and then storing the now transformed document off to blob storage. And they were able to do a lot of processing with very, very little headache. And the nice thing for them was that sometimes they have really no documents being created at all, and sometimes they had a lot of documents being created. And they didn't have to worry about, well, how does it scale? They don't have to worry about being called in to go and add another server because there was a big case and there was a lot of documents being uploaded. It just took care of itself. For serverless mobile backends, this is actually a big thing because a lot of our team came from the Azure mobile team in the first place. And we actually had a lot of examples where people were trying to upload images and do a lot of processing on them. And previously, we had to send them down the road of setting up a web job and all the pieces that came along with that. And web jobs are great technology, but they were relatively complex to get set up in the first place. And functions just made it so simple to do a lot of these pieces. So now you can have a mobile application upload a photo to blob storage and automatically have a function then go off there and resize the image so it scales to all the various sizes of screens that you might have. If you're doing mobile app development, it can be a real pain because every single form factor you want to support, an iPad versus an iPhone, you've got the big iPhone versus the small iPhone, you've got the large Samsung phones versus the very small Samsung phones. You want to make sure that you actually have several different sizes of that picture for thumbnails so that way they render properly on each of those places. Now you can do it very easily with functions automatically with very, very little overhead because it's simple to set up a resizer function without having to know very much about how computing works. This is really big because for mobile application developers, a lot of them are great at building mobile apps, but don't really know much about cloud development. And this now enables those mobile app developers to become full stack developers without having to really understand too much about how backend apps work. They're just writing functions that they know will work on the cloud fine. And so this is just expanding that scenario. I think I said it, and so we're not going to watch that through. But previously, this would have been insurmountable for someone who was a mobile app developer who didn't know very much about how the cloud or applications work, because they'd have to go through all these normal steps that they just couldn't be hassled with. They'd have to go find someone else in their team or hire someone to maintain this for them. And now these mobile app developers are empowered to do it themselves with very, very little extra headache that they have to worry about. They have to learn a little bit about, DevOps and proper monitoring of things and things along those lines. But for the most part, it takes care of itself. And especially for something like a business application where you're not going to be too worried about it maybe having a few bumps and hiccups, you could definitely have a mobile app developer take care of this. For something where it was customer facing, you might still want to bring in a backend developer just to make sure that everything is definitely going to run fine all the time. But it could probably be built by that mobile application developer and just maintained by a team that knows how to take care of cloud infrastructure a bit better. And so that's very nice. It's very, the mobile app developer is able to get moving there. And then same thing for serverless web application architectures. It's very easy to now go ahead and host a SPA on blob storage, serve it via Azure Functions proxies, and all of your APIs, all of your various notifications and processing for that web application are done via Azure Functions. And so it's very simple. You'll see a couple of these examples come out for build, because I think we have a couple of these things we're building for the build time frame, which is May, of how to build a web application without ever having to provision a server ever. It's just content hosted on blob storage and Azure Functions for the various APIs calls that you might have. So you can actually try this today. If you go to this very hard to read site, I'm sure. But if you go to tryfunctions.demo.blob.core.windows.net/static site/test tryfunctions.html, you can actually see an example of this that Yohai built for going ahead and uploading images and getting images into respective text box. So it's kind of a fun demo to try out. And then this is probably not quite as widely used as all the previous scenarios, but the people who are doing this kind of scenario are by far our highest usage. We have some customers that have been able to do, 1 billion events a day without having to call us. And basically the thing that's holding back a lot of customers is the need to process even more data than that. So, it's really been interesting to see how fast people can scale up when they're doing something like real-time stream processing of IoT data. This happens a lot for people who are doing large-scale manufacturing IoT implementations. They've got a lot of data that's flowing through there. Same thing for automotive companies that have been using us. We're able to handle a lot of data flowing in from all their various cars that they have with data flowing in there. So it really works out quite well in that particular scenario. And so this, a very simple way of thinking about that is I would have IoT hubs streaming in data, and maybe I'm processing it with Stream Analytics, or better yet, I've got an IoT data flowing in there, but it's sending me messages of some proprietary binary format that Stream Analytics doesn't know how to understand. But I can write a function which then takes that binary format and parses it to a JSON object, and then has that one sent out on another event hub, which then Stream Analytics can understand and do processing on. And in the event that we see any anomalies in that data, for instance, the engine needs to be handled, or a particular device on the floor needs to be shut down, I can then send a service bus queue message out of the Stream Analytics to a function, and have that function send a cloud to device message down to that device in IoT hubs to go and shut that vehicle, to shut the thing down, or tell it to slow down, or whatever I need to do. Send a text or notification to one of the engineers on the machine floor to go and deal with that device to make sure that it has high uptime, that it doesn't need to be shut down. I can preemptively try to detect that things might fail and actually have that engineer go in there and take care of that for me. So lots of very cool things that we've seen from this. So it's not necessarily something we've seen, the most number of people trying, because a lot of the cases these are very large companies that get into it, and there's just not a lot of people who work at that kind of scale. But the people who have gotten into it have been able to get to kind of a successful high scale place very quickly. And so I think that we're going to be really trying to encourage more of this stuff because it's great for us. We get to see some really high usage of functions, and we really liked, and it tickles us as an engineering team, frankly, to kind of see how people are using functions at that large scale. And it's also just enabling customers to do things that previously would have been really hard, having to set up all the infrastructure ahead of time, having to figure out the scaling strategy, looking at the bill of what this is going to cost for me to run all ahead of time really kind of slowed things down. And with functions, they started with a little trickle of data, and then as they started to throw real data into the pipeline, functions just scaled to handle it. And they didn't have to worry too much about how that whole process is going to work. If they decide that they want to stop sending the data because it just isn't useful to them or something along those lines, they don't have to worry about dealing with that kind of infrastructure management. It'll just naturally take care of itself. And so one of the interesting ways of thinking about this is a lot of people talk about IoT, Internet of Things, but there's actually a kind of a new set of scenarios. Internet of Streams is a word that I keep on using. Like we have a lot of data coming from services like Twitter, and you want to process them to go and react to various things. Let's say that someone badmouthed my company on Twitter, and I want to go ahead and have our support go and respond to them automatically. We can actually have every tweet that mentions our company go through a logic app, talk to a function, log that to SQL so we can kind of see sentiment analysis on things. And if it looks bad, like let's say that we run Cognitive Services emotions API on that text, and we get back that it was a bad message, we can alert our support team to go and try to address that immediately and try to save on potential frustrations that are going on there. And we can see a real-time Power BI dashboard thanks to that SQL connection of what are people saying about us, how many people are tweeting about us, is it mostly good, is it mostly bad, how are we doing historically on this? And that can be a very healthy thing for a lot of businesses to get set up quickly, because none of these things requires any kind of infrastructure management. It's all going to be serverless in the case of logic apps and functions, and fully managed in the case of SQL. And so all I really have to do is figure out the logic I want to have for analyzing tweets. And so one final demo here, and if you guys have questions, you guys should be asking them here, because we only have a few more minutes, and I'm happy to answer any questions you guys have around these things. One customer example we have, which really took functions to the next level, and really stands unique in how they've used functions, is Plexure. Plexure is a digital marketing company that has, they basically make it easy to react to various data coming from your customers. So one example is Plexure will make it easy that if a customer walks into your store with your mobile app on their phones and they reach an IoT beacon which says that they've entered your store, they'll go ahead and help you set up a workflow to go and look up that customer's preferences and send them a text notification or a mobile application notification with a coupon for a particular thing that you think they might like. And their goal is to try to increase the odds that someone goes to your store, increase the odds that when they go to your store that they actually buy something, and try to really encourage customer loyalty and improve the amount of transactions that you actually do as a business. And their unique piece there was that they were writing a lot of their custom processing pieces as Azure functions. And they realized, well, if we're writing these things as Azure functions, how hard would it be for us to let our own customers write their own custom plugins as Azure functions? And rather than just saying, hey, customers, write an Azure function and give us a URL that we can call, they actually took our portal, which we've open sourced, and baked it into their own portal. And they reverse engineered all of our management APIs and all these other pieces. And they were actually able to get it so that you could write an Azure function inside of the Plexure portal, inside of the Plexure subscription. So you never even have set up an Azure subscription. And now people are able to extend their SaaS service that they have with code without ever having to leave their SaaS service. This is, amazing for Plexure because now they get a lot more insight on what people are trying to do with their platform because they have all their code running in their subscriptions. And their customers never have to worry about setting up a subscription to Azure or AWS or whoever to actually go and extend the platform. They can just rely upon Plexure to run it end-to-end for them. And it reduces the complexity for both parties by a whole lot. So some final best practice thoughts to kind of leave you guys with. So as you're writing these things, think about trying to write thick clients and stateless backends, using a lot of spas and things along those lines. Just think about those lines. Stateless is great because it essentially helps you reach higher levels of scale without running into issues. The more state you have, the more memory you have to have, the harder it is to actually horizontally scale because you start running into vertical scale issues. Try to optimize for asynchronous patterns over synchronous patterns. It really helps to make a more resilient system in the first place. One way of kind of getting your head around this is I always like to point people at the Reactive Manifesto. It really is how highly distributed, scalable systems should work, and it's nice and simple. So if you can just take the things that they discuss in that manifesto and kind of understand that that's how applications should be built as much as possible, you'll get along with functions. They do jive really well. And kind of the other thing there is you really have to kind of dive in on the cloud. I've seen a couple of people try to use functions and try to use as many of their normal on-prem and other kind of service type things as possible, and they don't really enjoy it as much as other people do. Functions, you definitely can make it work with other things that aren't cloud-based technologies. When you're trying to talk to them, talk to on-prem, things along those lines. Especially if you need to do those things, but you're trying to move to the cloud, it's not a bad plan. But if you can, try to take advantage of all the things that the cloud has to offer. Using PaaS data services, using PaaS messaging services. Don't set up an Azure VM with RabbitMQ on it to try to do things. You're just not going to be as productive as you could be if you're using something like Service Bus and DocDB to actually manage your data and messaging services. So definitely think that. And oftentimes start one thing that it's not on this slide, but really for a lot of the cases where you're just trying to do a workflow automation, things along those lines, definitely start with logic apps, even over functions. Logic apps really makes it easy to orchestrate a lot of different calls to things. They have a lot of services baked in to talk to. So if I wanted to talk to Salesforce or Dynamics or SQL or DocumentDB or really all the things that functions talks to for the most part, they already have connectors to talk to all those things. And I can do a lot of it with even less code, basically no code inside of logic apps. And you can just use functions where you need custom extensibility and you need to write a bit more code, or maybe you need to talk to another service that you don't have an SDK for because it's an internal service, or it's just something that we haven't gotten around to building a connector for yet. So that works pretty well for the most part. So this is my call to action slide, which basically is the end of my presentation more or less here. So if you've never tried functions before, you can go to functions.azure.com to try functions. Functions is built on top of App Service, which is also a great way of hosting applications in general. So you can go to tryappservice.azure.com if you want to try that out. And otherwise, I guess we're at our hour here, more or less. So if you guys have questions, I don't have too much time, but hopefully this helped you guys kind of get up to speed with what functions is all about. I can't stress enough that it's just so simple to try that if you still have questions, just go to functions.azure.com, give it a shot. And a lot of times you'll just have a couple ideas come to mind of how useful it can be for your application, even before you start getting into the more complex scenarios that functions can support.
Thank you so much, Chris. The only question I have really is about migration from the app consumption plan to, well, we're getting a couple more, the app consumption plan to just the consumption-based plan. Is there a way to go back and forth, or is it kind of a set it and forget it type thing?
Right now, we don't have the ability to kind of go back and forth. We might get to that, especially if we get a lot of customer demand for that piece. I think what's interesting to me is the few times that I've talked about the scenario, a lot of times it's a customer that wants to always have at least one server around, but then wants to dynamically scale out. And so what I think we might think about doing is trying to get the normal app service plan to also let you use dynamic servers together, a kind of a together plan rather than swapping back and forth entirely. But it's something that needs more research, and it's not going to happen anytime soon. So today you'd have to expect that you're just going to go ahead and have to create two different function apps and move your code over and all your config over. It's not just a clean move an existing function app over to the different plan, unfortunately.
Cool. And then the only other question is serverless less susceptible to hacking than just having a standard app service plan?
I think it's got all the same security benefits, more or less, as a standard app service plan. I don't think that there's anything special that Functions is really doing there on top of app service itself to improve security. So I mean, really, the added security benefits to you are that since it's the Functions frame, you could potentially introduce security bugs in your web application logic layer. So if you set up your ASP.NET application with some weird stuff in it that was easy to make the application misbehave, Potentially Functions is more secure from that point of view because it's hardened. We've tested it with a lot of requests and a lot of weird things trying to get into the host. But that's basically it. Just maybe it's a bit more hardened than if you were to go and write something yourself. But otherwise, the sandbox and everything else that it's running in is just app service, which itself has been, battle tested over the last 5 years or so. So it's a pretty secure system for you to kind of get up and going with.
Awesome. Well, thank you so much. Wayne, do you have the community slide that kind of has the links to it?
Sure. Let me bring that back up.
Yeah, with that, we'll kind of close out with this last kind of slide that shows how to connect with us. It's the same one that you've seen on a regular basis. You can join us on the Yammer group for further conversations. If you have questions, post them there. I can certainly direct those back if we need to, and so we'll certainly have that capability to get in touch with Chris if you have some further questions you want to take a look at. We will be posting the slides from today's call on the Yammer group. Take a look at the blog as we will continue to have information there, and make sure that you sign up for future calls. We appreciate you guys joining us for the call today, and we hope that you stick around and answer a couple questions for us on the survey. It helps us put this content together and lets us know how we did and what you want to see going forward, so we can really shape these kind of meetings to provide the best value to you guys. And with that, I'll go ahead and close and say thank you. Good morning, good afternoon, and good evening for the rest of your day.